Good morning, good afternoon, good evening, whenever, wherever you are, welcome. We are moving into chapter 5, which is respiratory function. Totally bread and butter stuff for you guys. And I'm excited to get going on this chapter. So, as always, we need to start with the basic structure of the respiratory system. And your book, as well as I, teach this mostly with pictures. Many of these structures probably seem somewhat familiar to you. We may go over a few new ones. As always and forever, if you have any questions, shoot me an email. So with the respiratory system, there's basically two main divisions, and some people even teach this with a third. The first is obvious. It's air coming in, air moving out. We'll talk about those physiological processes. We're going to talk about the nose, the mouth, the trachea, the bronchi, the bronchioles, all familiar, I'm sure, to you. We'll go through and look at those on a picture. Now, once we bring the air in, we've got to get the oxygen into the bloodstream. That's the whole goal. That's why we pump blood from the heart to the lungs, is to get that oxygen and to offload carbon dioxide, so gas exchange. Some anatomy and physiology texts take it even one step further, and I want you to just realize this. We're not just throwing the oxygen into the bloodstream to throw it into the bloodstream. It needs to then be put into the cells of the body. Okay, so, and that's a whole process in metabolism that if we don't have time to go over with, I will send you a link to my anatomy and physiology lecture for that. Because metabolism is an important processes, many processes that are good to have a fundamental knowledge of. So I want you to just realize that the whole goal of getting the air into the bloodstream or the oxygen into the bloodstream is to get the oxygen into the tissues. Once they're in the tissues, they join with glucose to create energy for us. The byproduct or the waste products of that process is carbon dioxide. So then those cells will send the carbon dioxide back into the bloodstream to be turned back to the lungs to be gotten rid of on our expiration. So oxygen comes in through this air conduction. I'll show you exactly where it transfers over into the bloodstream. At that point, we're also offloading carbon dioxide into the lungs to be gotten rid of when we exhale. That oxygen goes out to the tissues. It joins with glucose in the cells to create energy. The byproduct of that is carbon dioxide, which is put into the bloodstream, sent to the lungs, so we're ready to get rid of it or exhale. That's a whole general gist of why we breathe. Now, the respiratory system also helps to balance pH. Carbon dioxide, sorry about that, I touched my screen. Carbon dioxide, going back to this slide, is acidic. For those of you who don't remember, when we're talking about pH systems in the body, and we'll be going over this, don't worry, CO2 is acidic. So if you breathe in too much CO2, you will become more acidic. If you get rid of too much CO2, you're going to get too alkalinic, and that changes the pH, which we'll go into. But just get into your head right now, CO2 is acidic. And that helps you to remember if you've kept too much CO2, such as in emphysema, which we'll go over. If you get rid of too much CO2, then you're, let me continue that thought. If you keep too much CO2 when you have emphysema, you are going to become more acidic. If you're hyperventilating and you get rid of a lot of CO2, you become more alkalinic, and that changes the acidity of the systemic pH, which can change many physiological processes in our body, and we'll get into that. So, excuse me, different functions of the respiratory system, other than bringing in that air, things that help to protect that air as it comes in. We have mucus along the respiratory tract, and that helps to trap harmful substances along with cilia. When I lived in London years ago, when we would go on the subway, I'd get out and blow my nose, and there would be a ton of dirt in my respiratory system that the cilia in your nose, which are your nasal hairs, and the mucus that lines your nasal respiratory passages would trap that dirt. That's part of their job as a protective mechanism. and then you could blow it out so it doesn't get down and into your lungs. We also have immune cells in the respiratory system, in the alveoli specifically we'll talk about, that help to protect in case some junk gets in there, and not just in case, it gets in there. We're exposed to virus and bacteria and fungi all the time. There's capillaries in the nose which help to warm and humidify the air and protect the system from drying and damage from the cold. That is also part of the sinuses. So the sinuses help to warm the air that come into and out of our nasal cavities, and they also help to lighten the skull, the sinuses, the paranasal sinuses, for example. So let's go over those structures. Just breathe, okay, or take a breath. So nasal cavity filters and warms the air. Oral cavity transports air to the common tube known as the pharynx. I'm going to buzz through this. We're going to look at all these structures, okay? But these give a great definition of what these structures do. So the pharynx is a common tube before it bifurcates into the trachea, which is at the top of the larynx, and the esophagus, which goes to the stomach. The epiglottis covers the trachea. During swallowing, it prevents substances that are not meant to go into the lungs, not to go into the lungs. The larynx is where our voice box is, helps to filter incoming air, helps to warm and moisten the incoming air. The trachea and bronchi also warm and moisten the air and transport it down to the lungs. They're a patent open tube held open by cartilage. The bronchioles help to control the airflow in the lungs. This is something I think we'll talk about in a few slides. As you start, but let me give you the general concept now. If we were to look at the trachea, it's a pretty thick tube. There's muscle in the back, there's cartilage in the front with the trachea. That cartilage helps to keep the trachea open. And that is because breathing is a passive process. I can't gather up a bunch of air and shove it down my throat. I have to change the pressure within my thoracic cavity to move air in and out. The trachea is held open by cartilaginous rings to allow that passive process to happen. Now, as we move down into the bronchi and somewhat into the bronchioles, the tube gets smaller and thinner. We lose the cartilage, and eventually it turns into little bags called alveoli, which are just one simple squamous cell thick. And that's a smooth transition from the thick trachea down to the simple squamous cell. And simple squamous cells around the alveoli, guys, are just one cell that are pretty thin. And they're thin so we can easily transport oxygen and carbon dioxide between the alveoli and the lungs into the capillaries in the pulmonary circuit. Okay, and I'll show you a picture of all of this. Now, looking at the upper respiratory tract, we're going to be looking at it from the larynx up. Okay, I've heard different things from different places. For these notes and these purposes, your book includes the larynx and the upper respiratory tract. So you may have learned it differently. That's okay. I just want to keep things consistent between the book and the notes. So larynx up will be the upper respiratory tract. That includes the nasal cavity, which some of us know as the nasopharynx. We'll go with nasal cavity. The oral cavity, and you can see they can join together into, oh, I'm sorry, this is the nasopharynx. This is the nasal cavity. This is the nasopharynx. I apologize. And this is the oropharynx. Okay, so the pharynx in general is going to go from the back of the nasal cavity all the way behind the larynx. And this is that common tube that carries food and water before it splits and goes to the respiratory system or the GI tract in the esophagus. And as we pass through the larynx, we'll then move into the trachea. And you could see the trachea is cut in half. You could see the rings of cartilage here. They're cut. They're little C-shaped rings in the front of the trachea. So here is the epiglottis, which covers the larynx. So when we swallow food, this will close down and prevent substances from coming into that trachea. Let me erase this. It'll prevent food from getting into the trachea because that would be bad. It can lodge itself in the lungs. The epiglottis instead will shimmy things down into the esophagus, so food will go down to the stomach. The other thing to keep in mind is we will have substances. So if we do inhale a little something, or we get some excess mucus or dirt that goes into the lungs, the body actually will take the cilia and push it up, and it'll go down into the digestive tract to be digested. Okay. You can see one of the sinuses here. This is actually sphenoid. It's deeper in, but they're good open space that'll lighten the skull and also moisten the air. Here's frontal. Moisten the air as it comes in and goes down to the respiratory tract. Looking at the lower respiratory tract here. So this will be trachea, those thick cartilaginous rings. And the rings are C-shaped in the front. So if you were to cut the trachea in half and look inside from the top, there's cartilaginous rings in the front, but there's also a little bit of muscle in this back part, just about from here to here when we're looking at the trachea. As the trachea bifurcates into the right and the left primary bronchi, and then it goes secondary and then tertiary bronchi as it moves out into the lobes. They'll have cartilaginous rings as well in the primary, secondary, and tertiary bronchi, but they are getting smaller and thinner. By the time we get out to the bronchioles, okay, you'll have a bronchiole leading down to an alveolar sac. So the bronchiole is pretty small, and the thing to remember about bronchioles, and this is important, so write this down, this is where smooth muscle is. This is where we get the responses in asthma, where the bronchioles tighten down due to an overreaction in asthma, and that smooth muscle tightens down and you can't get air in. At the end of the bronchiole, then, we'll have groupings of alveoli, which you probably remember. They look like grapes on a stem. And that's when we get the thymus membrane that's one cell thick. And around them, you can see it's a little bit confusing. So these are the alveoli by themselves. These are the alveoli with the pulmonary veins, capillaries wrapped around them. And it almost looks like fishnet stockings covering that grape-like cluster of alveoli at the end of the bronchioles there. And the pulmonary capillaries, you can see, this is an even closer picture of them, are also one cell thick, so it allows the exchange of oxygen and carbon dioxide quickly and efficiently. If we look into the larynx itself, okay, there are some cartilages and structures that you need to know. In the front of the larynx, so this is the larynx and the trachea blown up. And this is just about as if we cut somebody right in half into perfect right and left halves. And we're looking at these structures right down the midline, okay, is what we're looking at here. We've got the epiglottis, which is considered part of the larynx. You do need to know that. The thyroid cartilage, which is the front of the larynx, and that'll provide our Adam's apple for us in the front. And then you have false and true vocal cords. And the true vocal cords are here, and the false are just above them. And the true vocal cords, if you were to visualize them, if you were to scope somebody and look inside, the true vocal cords actually touch. They come together, this shows them apart, but they actually will touch when we're talking. And when we move the air across them and they close together, they create the intonation of our voice. And just above them here are those false vocal cords, which I think just provide a site of attachment for cartilage, but they don't provide the actual creation of the voice itself. Now looking down a little bit further, so if we were to continue down with that intubation, go through the vocal cords, this is the bifurcation, which is a fancy word for saying the split of the trachea at the carina into right and left main stem bronchi. Okay, so the carina is the last cartilage that's right about here before we split into the, I think this is the right, because the right tends to be more vertical. I think they have it transposed, I think, from what I can tell, because the right is a little bit more vertical, which makes it easier for things when we inhale them to go to the right side of the lungs. So the right primary bronchus will be more vertical. So that's a good thing to make note of. So anyway, that's a split before we get into those primary bronchi at the carina. Good structure to know. All right, so these are the cells, the microscopic cells, as we look along the lining of the trachea and probably down into the primary bronchi as well. These cells, yes, we're going to talk about cellular things, are simple columnar because they are actually, they're pseudostratified, ciliated columnar. Okay, I'm not going to get too much into that. Know that they're basically tall cells. You do need to know that they have cilia on top of them. And the cilia that lines the trachea are important because they will trap dust particles and they will actually push them back up, not into the mouth. It will go into the esophagus. Okay, it goes right up and over into the esophagus, so just cross that out. All right, so that, and also we have goblet cells, which are also known as mucous cells. So if we were to blow this picture up and look along here, and we're along the lining, don't forget of the trachea and a little bit into the primary bronchi, these mucus secreting cells are known as goblet cells. And they secrete a layer of mucus onto the surface of the respiratory tract to once again capture dust and push it back up to be popped right over into the stomach, and the stomach basically digests it and eats it up. And that helps to keep that airway clear. Now, unfortunately, people who smoke, I really hope none of you smoke, but if you do, you lose the motility of these cilia, and you're more prone to keep dust particles and dirt that'll go down into the respiratory tract. So quit if you smoke. Bad news. All right, this is looking at an alveolus, which are those grapes on the stem at the end of that respiratory system after the bronchioles. And you can see along here there are different cells that you do need to know the basics about. It's very simple. There are three main cells we're going to talk about. Type 1, easy peasy. It just lines the alveolus. It's those simple squamous cells. They look like little egg-shaped cells, one cell thick, that line the alveolus so we could get the transportation of oxygen, as we can see here, out into the pulmonary capillary very easily, and the carbon dioxide into the alveolus from the pulmonary capillary so we could get an exhalation and get rid of it. Type 2 produces surfactant. Surfactant is important because it helps to break apart water molecules that are in the alveolus. If we don't have enough surfactant, such as when a baby is born too young, we can't break down the water that is in the alveolus, and the alveoli can collapse, thereby allowing all alveoli to collapse, and the lung will collapse. That's why children, if they're born too young, need to have the artificial surfactant. The final cell that we need to know in respiratory is an alveolar macrophage, which is going to do exactly what you think it's going to do. It's going to hang out in the alveolus, which is singular. Alveoli are plural. And these little guys wait for stuff to eat up. Anything that may have snuck down, infectious agents, maybe a little bit of dirt, a little bit of dust. It's hanging out in there just waiting to eat things up. It is question time. Now, this one we are looking at question or number 8 of this question. On the picture, number 8 is A, part of the upper respiratory system. B is used for swallowing. C is made of bone. D is the trachea. Good luck. I hope you get that one.